What is current? What is voltage? For example, use steel balls to represent electrons and a pipe as the wire. Steel balls don't move in the pipe because there is no pressure. Now, if we push one ball in with an external force, the push makes all balls in the pipe move one step. That is current. Why is copper often used as a conductor? Because each copper atom has 29 electrons, one outer electron can move freely. This electron can move between nearby atoms, but their direction is random with no uniform flow. If you measure its ends with a multimeter, you will see no voltage difference. So this movement cannot be called current. But if you connect both ends with a 1.5 volt battery and wire, now there is a 1.5 volt difference across the copper. This voltage difference forces electrons to move in one direction. This flow of electrons is called current. Of course, connecting directly causes a short circuit. You must add a load in between like a bulb. The bulb acts as a resistor, limiting current and preventing short circuit. The bigger the resistance, the smaller the current. Current is measured in amperes. It is represented by the letter A. Then what is voltage? This is a bit more complex. For example, here is a water tower. Due to gravity, water presses downward on the pipe. This pressure in a circuit is called positive pressure. Then what is negative pressure? For example, with a syringe, when you pull the plunger back, negative pressure is created. Inside this negative pressure is suction. Of course, for electricity, gravity has almost no effect. But circuits have positive and negative pressure. Take this battery as an example. Its negative terminal is like the water tower. It has extra electrons pushing out into the circuit. The positive terminal is like the syringe. It lacks electrons pulling them from the circuit. So if we connect both ends with a wire, electrons will flow from negative to positive. You can place components in the circuit like a bulb. When current flows through them, it produces effects. Like water under higher pressure can do more work. It can turn a water wheel faster. If pressure is too small, water passes but the wheel won't turn. Like a 9 volts battery cannot light a 220 volts bulb. Though the bulb won't light, electrons still pass through. Finally, when the electron difference is 0, the battery is drained. Electrons stop flowing and components produce no power. Alright, I'm done. Did you understand?